All right, functions part 2. Let's jump right in, pick up where we ended last time, which was this max function that we wrote together and we fully tested. It was write a program that will call another function max to determine the maximum of those two numbers. We had the problem solving phase. We want to have this algorithm where in the working area of our program, we're going to have these two numbers that the user will enter. After the user enters those two numbers, we're going to then call this max function, which of course means we need to have this max function. Max function is pretty straightforward. It's going to merely receive those two actual parameters, save them into those placeholders, the formal parameters, and it will determine which of those two numbers is larger and will return that result. We will also have a main function which will read those two numbers from the user. We'll call this max function, and then we'll print the result when we finish. So since this is just a warm-up and a review of last time, let's run right over to the code, and this is what we came up with. We have up here our max function, we have our main function, and then of course we have on line 24 our initial call to that main function, because if we got rid of that call and I simply run this code, there's nothing to happen. All I have is I have a function here and a function here, and Python's like, okay, I know you have two functions, good for you, but nothing actually gets executed because I never called that initial function. So here I'm calling main on line 24. I come to my main, I run my main, I read these two numbers from the user, then I get to line 18, I have an assignment, so our eyes need to do what? We need to look to the right side of that assignment, and we see we have a max function. This max function has two arguments, two parameters. What are those two values? It's the two numbers that we read in from the user, num1 and num2. Maybe num1 is 5, maybe num2 is 3, whatever those two numbers would be, and those two numbers will be the actual parameters that we're going to send over to this max function, because we're calling the max function, and we're going to send over 5. It will come right here. The 3 will come over right here. And then we're going to compare, is 5 greater than 3? It is. So the max will become 5. That will come right here. It will get returned. And when it gets returned, it's going to come to right here. It returns to the exact place from which you called it. And so now the max number has the value of 5, which we can print right here on line 21. So let me undo those changes, and let's go through this very quickly. It's worth debugging this as a nice reminder. So when I debug, and now I'm just going to hit F7 on a Windows-based machine, so we can see what the Python interpreter, how it examines this code. So here it says, cool, I got you. I see you have a max function. Okay, I got you. I see you have a main function. Line 24, it's like, okay, so we're going. We're calling main right off the bat. So when we call main, and I love Thani here, because Thani now, it opens up a great visual for us. Now we have another function, that main function that just opened. Back behind was our main working area of the program where we called that function. This is on pause. And let me even start over, because I want to come down here, and I want to put a print statement. And now we are here on line 26, printing after everything is done. All right, zoom out just a little bit. Let's see. Come on, zoom. There we go. Okay, so now, because I want you to see when we get to this point. So one more time, let us debug this. Python's like, I see you have a max function, I see you have a main function, let's call that main. Great, so we're on line 24. Python calls this main function right here. I just want to move this over a bit. We call this main function, and here we are. In our main, we're going to run through this. Python says, it reads where we're asking the user to enter an integer. Let's say we enter those two numbers, 5 and 3. We enter 5. Let's enter a larger number, actually. Let's enter 5 and 12. Here's the second number, 12. And so notice we convert that string 12 to an integer, and we save it into num2. So now we have num1 and num2. It's very tiny. I'm not sure if you can see this. We have num1 and num2, 5 and 12. Now, on this line of code, we're calling, this is an assignment, we're going to call that max function, And when we call this max function with 5 and 12, these are the actual parameters. Remember, we have actual parameters and formal parameters. The formal parameters are these parameters right here. These are called placeholders, is what I also call them. But they're the formal parameters. They are the receiving points to catch the parameters that are being thrown over at it. So we're sending over this 5. Where's this 5 going to go? It's going to come to num1. Where's this 12 going to go? It's going to come to num2. So when I hit F7 now and we call this max function, look what happens. Now we have another function open. So again, this is our code back here. We're on line 24 right now. Line 24 called main. Here's the main function. It's open. So line 24 called main, and it opened up main. And so now line 24 is on pause. It's waiting to do line 25, but it can't do line 25 because line 24, the main function, has not completed. So here's the main function. Well, in the main function, we have 1, 2, 3, 4, 5, 6, 7. We have like 10 lines of code. Well, we're on number 7 right now. And line number 7 is calling the max function, which is right here. So now this main function is also on pause, waiting on the result from the max function. So we sent over the value 5 and 12. 5 came to num1, 12 came to num2, as you see here. And we continue. I hit F7. Like, I'm gonna have to run and do that real quick. Don't hit the wrong button when you're doing that. I'm gonna run through this very, very, very quickly. This is gonna be 5, and this is going to be 12. And here we are back where I was just showing you. Okay, is 5 greater than 12? It is not. That is false. So now we come to the else statement, and we're going to assign the value 12 into the variable the max, and then finally we return the max value. So the question is, where does that get returned to? So when I'm returning this value 12 right now, where does that 12 get returned to? Return 12. It gets returned to the location that called this function, right? Someone called this max function. Where did we do that? We did that right here in this line of code. On the right side of the assignment, we have max 5, 12. The result of that is clearly 12. So once we determine that 12, where does it return to? It returns right here. So I'm going to return it, and then all of this right here became 12. We save 12 into this variable, the max number. So now we have the max number is 12, and we can then print the max of 5 and 12 is 12. And now that we have printed this, let's make sure we get that output. We print, we're going to see the output here. And so now this function, the main function, has completed. Line 24 is done. And now we come to line 26. That entire time, this main working area of your program was on pause. Line 24 was paused. It was waiting for the main function. The main function was waiting for the max function. Now that those are finally done, we can come back and we can print this statement, and the program has completed. That's a long review, but it's worth it. With that in mind, let's now jump in and solve some other problems. So we've seen functions with return values. We can also have functions without return values. That last example of max, it returned that maximum value. Some functions don't return anything at all. In programming, we call this a void function. The following program we're going to write is simply going to determine the letter grade for a student based on the numerical grade, and we're merely going to print out the letter grade for a given score. So here's the program. Write a program that will call another function. That function will be called print grade, which will determine and print the letter grade based off of a given score. Your function should not return anything because it's merely going to print. So as always, we have the problem-solving phase first. So your program should include the following. Your program should include a function called print letter grade with a single argument, a single parameter called score. This function will take in this one parameter, a score. Maybe the score, I say here, is 84, which is going to be a B. Your function should then print the letter grade based off of that score. You also need to have a function called main which does three things. Remember, we said that from here on out, we will always put any code at least into a main function. So we're going to have a main function which does three things. It's going to ask the user to enter a score. Once the user enters that score, your main will then print out the grade is, and it will pause on that line. It will not print a new line because we want to print the letter grade for that score. So you're going to print, you will not print the numeric score, and again, you will pause on that line. You will print the grade is, because what's going to happen now? We're going to call the print letter grade function, and we're going to send over the score to that function, and we're going to ask that function to simply print a B, or to print an A, or a C, or whatever the letter grade would be based off of the score. And then finally, your program needs to have an initial call to main. So that was a solution you saw briefly. Pause the video, leave this here, page 34 on the screen, and try to actually code this up. I'm going to go code it up for you as well, but I want you to try to code this up on your own. So pause the video, try to do that, struggle a bit, but you have the instructions here. You have the three things you need to do. You need to make this print letter grade function. Make sure you understand that function is merely going to print an A, a B, a C, a D, or an F. That's it. You have a main. What is main going to do? It's merely going to ask the user for a score, enter a score. It will print the grade is space, and it will stay on that same line using the end equals a pair of double quotation marks. And then we're going to call the print letter grade function, which will print the A, the B, the C, the D, or an F. And then finally, you have to call your main to actually start your program. Leave this on the screen, pause the video, and try to code this on your own. Struggle through it if need be. It should take between 5 to 10 minutes. And then come back, and here I will code up a solution. So File, New. Let's save this, and let's call this print letter grade. All right, let's get right to it. We need to make a function called print letter grade. Define print letter grade. It takes one parameter. We called it a score. And all we're going to do is check if the score is greater or equal to 90, print an A. That's it. Elif score is greater or equal to 80, print a B. Now, I will say I've seen a lot of students say elif the score is greater or equal to 80 and score is less than 90. There's nothing wrong with that, but that's doing the same thing, right? If the score is greater than 90, print an A. But if you make it to here, what does it logically mean right here? If we've made it down to this far, the score must be less than 90, logically, right? Because it's either greater or equal to 90 or less than 90. So there's no need to check if it's less than 90 right here because it's automatically less than 90 by virtue of this if statement being false. So we don't need to put this. So elif the score is greater or equal to 80. We want to print a B. I'm going to copy paste, make my life a bit easier. So that would be a C, a D. Finally, this would be else print F. So this is going to be here a C, and this will be a D. This is going to be greater or equal to 70, greater or equal to 60, otherwise an F. That's it. We're just printing an A, B, C, D, or an F based off of the given value inside that formal parameter score. So now we need to define our main. And you know what? Because we're going to probably forget otherwise, I'm going to come way down here and I'm going to go ahead and make our initial call to main. Make the call to the main function to start our program. So now let's go code up the main. What does main have? Ask the user to enter a score. I'm going to put this exact text. So score equals int input enter a score colon. Done. Now what do? We want to print out the grade is, print the grade is, and I want to leave the cursor on that same line, right? Because I want to go ahead and print an A, B, C, D, or an F right there. And then finally, after printing that, I need to call the print letter grade function. So now let's call the print letter grade function to print the A, B, C, D, F. So print letter grade, and I'm going to send over this parameter score. So if the user entered a 65, well, I'm going to send over 65. This will right here, the formal parameter, it will become 65, and then we're just going to go through that logic. So I think this looks good. Let's run it first. Enter a score. Let's check 65. The grade is a D. Let's enter a score. 98. The grade is an A. Let's go ahead and now debug this so we can see how this is working. So I'm going to hit F7. Python sees we have a print letter grade function. Python sees we have a main function. Now Python makes the initial call to main. Here's the main function. And let's keep hitting F7. Enter a score. Let's enter in, how about 73? And so here's 73. It's read as a string. Then we convert it to an integer. And so now score is 73, and here's the variable. Print the grade is. So we print the grade is, and we're staying right here on the same line. And now we're calling the print letter grade function, and we're sending to that function this actual parameter 73. So here's that call, and here's that function that popped up. We have scores already sent over. So score right here, it's a 73. That actual parameter was sent over and was saved inside this formal parameter score. Now we just have this if-else block, which we know how to do very well. So is score greater or equal to 90? Nope, that's false. Is score greater or equal to 80? Nope, that's false. And notice how Python looks at the rest, the entire block, as one block remaining. Is score greater or equal to 70? Yes, it is. That's true. We print a C. So a C gets printed right here on the output. And now we're done with this. That function finished. And even main has now finished. And we're back at the main working area of our program. Very cool. So that, I think we're slowly going to get more and more comfortable with functions. It's really just all about practice. So that was print letter grade, and here was another implementation. Program number 4, pretty similar. This one, however, here instead of printing a letter grade, we want to actually return the letter grade. So it's going to look identical. We're going to ask the user for a score. And then we're going to print out the grade is that score. But now we don't want the function called print letter grade. We don't want it to print the letter grade. And in fact, we're going to rename that function to get letter grade. And that function, instead of printing a B, for example, it will return a string with a B inside it. So same thing, problem solving phase. What you really should do is take your last code and make a copy of it. Make a new program and paste that new code into the new program. Or the easier way, I'm just going to hit File, Save. And instead of saving this now as print letter grade, I'm going to call this return letter grade. I should have said program. Return letter grade program. So this is not going to be called print letter grade. It's going to be called get letter grade. So we want to edit this code accordingly. The program is going to be the identical functionality, except now that function, instead of printing a letter grade, it's going to return a letter grade. So you have to think about what's going to change in your main. So here, define get letter grade, not return, get. I'm sorry, not print letter grade, get letter grade. So we no longer want to print A, B, C, D, or F. Instead, we want to return a letter grade. We want to return an A, a B, a C, a D, or an F. So think of how that will change the code. Pause the video and try to really think about that and make the appropriate changes to get this to work. Again, we don't want to print. This will not print anything up here. Instead, we're going to return a letter grade, which means this output down here is going to be a little bit different. Pause the video, spend 5 to 10 minutes, and then come back, and here is a solution. A couple of things. Well, I'm going to do, here I'll code it the way most students would normally code this. They'd probably say letter grade equals A. Nothing wrong with that. We'll do this for all of them. letter grade is B, letter grade is C, letter grade is D, letter grade is F. And the reason why most students will do this, and then they'll come down here and they'll say, return the letter grade. Return letter grade. Nothing wrong with the solution. It works perfectly fine. And the reason why most students would do that is because if you did the right thing and if you were stuck and you're like, well, let me go look at a previous program, you come to this max program and you say, oh yeah, I took num1 and I saved it into this variable, or num2 into that same variable, and then I returned the max. So let's do the same thing. I'm going to take an A or a B or a C or a D or an F, save it into this variable letter grade, and then return letter grade. Nothing wrong with that solution. So I'll leave that here for now, then I'll make an update to it in a few minutes, but that solution will work just fine. So what else needs to change now? We have this score equals int input, enter a score. That's perfectly fine. And then we have this print statement. The grade is, and what do? Well, if you're stuck, you come back and hopefully you look at this one and you look at what did we do? How did we call the max function? Oh, here we called it. It returned, maybe the maximum was 5, and it saved 5 into a variable, which we then used to print. So if you want to take that same approach, no problem. What you would do is the following. We would now call the get letter grade function. So let's call this maybe letter grade, or how about the letter grade, just to use a different variable name to make things clear. Get letter grade, and we send over the score. So what's going to happen here is I'm calling this get letter grade function, I'm sending the score, and it's going to check the score and it's going to return to me a grade. Maybe it returns a D. So all of this, when it gets returned, will be a D. No harm, no foul. All of that will be a D. And then I can print the result. I can print the, what was it called? I think it said the letter grade is, right? Let's come over here. And we have the grade is. So the grade is, we put placeholder, dot format, the letter grade. So that's it. That's the changes we would make. And how did we make those changes? By comparing to an already working program that was returning a value, and we saw, oh, it returned it here. I saved it into a variable, and then I printed that variable. Nothing wrong with that. That's not how I would usually code it. Once you're more comfortable with calling a function and getting the return value, you can really skip this step right here, and I'll show you how in a moment. But first, let's go ahead and debug this program. Let me zoom out just a little bit so we can see everything on the screen. And let's run it, make sure we didn't make a mistake. 98 is an A, the grade is A. Why is that printing twice? So I didn't get rid of line 18. So now let's put 98. The grade is A. Let's put 62. Oh, that's fantastic. 62. Oh, I thought I put 62. That was a typo. 62. The grade is a D. Cool. I was worried that didn't work. All right. So now let's debug it. And when we debug it, as always, the Python interpreter, it sees, oh, you have a get letter grade function. Cool, I got you. You have a main function. Cool, got you. Main, now we call it, here's the main function. It pops up. And we're going to now ask the user for a score. Let's enter 62. And we're going to now examine, the Python interpreter examines that line of code. It sees it's an assignment. It goes to the right side, and it calls the get letter grade function with the actual parameter 62. So we're now calling this get letter grade function, and even look up here. It says get letter grade 62. It's beautiful. This debugger is beautiful as an educational IDE. So now we have the score is 62, and what remains is just to go through and check, is 62 greater or equal to 90? Nope. Now it checks all of the remainder. Is 62 greater or equal to 80? Nope. Is it greater or equal to 70? Nope. Is it greater or equal to 60? Yes, it is. So pay attention what happens here. That's going to be true. So what happens is we will set letter grade to D. You see there's this variable letter grade, and now we're going to return letter grade, which is a D. So we're going to return that D. Where does it get returned to? To the place that called it, right there. So now the letter grade is D. You can see right here we have this variable, the letter grade is D, and we can now print the grade is, and we print out we have the grade is placeholder, and we print out the D, and we are done with the program. Pretty easy. So what changes did I say that I would make to this? Well, the first thing I would make, this is okay. I could change this up here, but the main thing that I would change is once you're comfortable with this, and you're comfortable with this assignment, and you're particularly comfortable with the right side of the assignment, what happened here is we're calling the getLetterGrade function. We're sending over that score, which was 62, for example, and the result of that function call, the result is it's going to return a D. If you're comfortable with that, then I would say, you know what? Because think of what's happening. We're merely taking that D, all of this results in a D, we're saving that D into a variable, and then we're printing that variable. There's no harm to save it into a variable and then print the variable. But if you realize we're just saving it into a variable and then printing that variable, and you realize there's no need to do that. Or what if I said, let's make another variable called W equals the letter grade, and we save the letter grade. So remember, it was D. We saved, or let's just call this another variable. Another variable. We save the D into the letter grade, then we save the letter grade into another variable, and then we print out another variable. You would say that's kind of silly. Why would I do that? It is silly. Or let's say yet another variable equals another variable. This is really overkill, but I'm trying to make a point here. So here we save D into the letter grade, then we save the letter grade into another variable, then we save another variable into yet another variable, and then we finally print it. You're like, what the hell are you doing? I'm trying to make the point that that's really silly, right? Why would you do all of that? Well, in that same vein, I would say it's kind of silly once you're used to it. There's no need to save the getLetterGrade, which results in a D, save it to a variable, and then print that variable. There's no need. Why not just take this right here, the getLetterGrade, and put it directly right there? And some of you are like, what just happened? And you're like, your mind has been blown. So here, look at what's happening. I'm printing the grade is placeholder. And what gets printed inside that placeholder? The result of calling this function. So we're going to call the function. What gets returned? A D. And then that D gets printed. So that's what I would have done right here. I would have just called the function directly. I would not have used that other variable. That's the first thing. And then the second thing, I would sometimes code it like this, or you would realize, well, there's no need to actually save each of these, this A into this variable or the B into this variable and then return that variable. That's one way of doing it, nothing wrong. Or you could just say, you know what, how about if the score is greater or equal to 90, just return an A. If the score is greater or equal to 80, return a B. If it's greater or equal to 70, return a C. Greater or equal to 60, return a D. Else, return an F. Now that's kind of unique. Most of you probably didn't do that because you might be thinking, oh, I didn't know I could put 1, 2, 3, 4, 5 return statements. Well, it's not really 5 return statements. It's only one return statement, but it's based off of the truth of a given Boolean expression. So if this is true, return A. If this is true, return B. Otherwise, return C or D or F. So this is how I would have probably coded this problem, certainly at least this way. But to be honest, I think for beginners, I think to save the choice of A, B, C, D, or F into letter grade and then return letter grade, I think that's a little bit cleaner for new students. So here's a solution to that problem. And we have couple more slides and then one more problem and we are done. So what are the slides? I want to introduce this idea of a none function. What is a none function? Technically, every Python program actually returns something. Perhaps as I've been debugging these, you may have noticed every now and then the debugger, it says none when it's done and it's trying to return. It actually says none, and you might have wondered, what is that? Well, in fact, every Python program returns something. So if you don't explicitly return and type the return keyword and return a string or return an integer, what happens is Python returns a special value called none. Thus, functions that do not explicitly return a value, those are called none functions in Python. So a return statement is not needed for a none function. And so perhaps you remember, let me go here, save, I'm going to come, I'll just save this over garbage. Yes. So here, if we have this function, define print something, and inside here we just print hello world, and then we now call print something. We call this function to actually run it. So the result is hello world. When we debug it, let's very quickly debug it. Python, notice we have a function. It says, cool, I got you. Here we call the function. Here's the function. It prints hello world. Here's that result, hello world. And then notice this none. It returns none. And notice I didn't put return in here at all because you don't have to explicitly type return. But if you don't type return, just know that none gets returned. And even here in your main, none gets returned. So this is a none function. So you can include your own explicit statement of return none. Might feel kind of strange, so you don't have to do that, but that is a none function. Also, this idea of a function call stack. What happens when you actually call a function? The system creates what is known as an activation record. This activation record, don't be scared, it's just two words. It's not some scary term. But what it is, it's an area of memory that stores the parameters, that formal parameter that you send over. It's an area of memory that stores the parameters for that function as well as any other variables that are for that function. This activation record is then stored in memory in an area of memory known as the call stack. And it's called a call stack because it really just looks like a stack of a stack of books, a stack of trays, and it's treated as a stack. So each time a function is called, a new activation record is made and it's placed on that stack of called functions. And I say here, note, the caller's activation record is kept intact. It's still on the stack, and it's just that the activation for the new function is placed on top of it. The activation record for the newest function call is placed at the top. And so we have this last in, first out order of these activation records. Think about what that means. The example given, usually cafeteria trays. Where do you pick up a cafeteria tray from normally? Unless it's dirty. You pick up a cafeteria tray from the top, right? The last tray that was placed in. Imagine the worker comes out and they put 50 trays into the stack. Well, the very last tray that was put on top of the stack, that's the first tray that's going to come off of the stack, right? So a stack is a last in, first out access policy. The last tray into the stack is the first tray off of the stack. Well, the same thing goes for functions. The last function to open up, the last function to be called, or the most recent function you could say to be called, is the one that's at the top of the stack. And that's the one that's currently executing. This is the idea of this last in, first out access policy of a stack. So what I'd like to do is draw one out for you briefly. So coming over to this program that we've already coded up, this is that get letter grade function, and we have here our main, right? This is everything we already saw, right? We have our get letter grade function, we have our main function, and then we have our call over here to main. So what actually happens is, let me draw out a stack, because it literally looks like a stack. Here's the stack. What happens when we call main right here? Let me click the red. When we call main, what happens is a new activation record opens on the stack, and main is called. So let's think of this here as an activation record on the stack. And it's basically, and notice that the stack prior to this, the stack was what? It was empty, right? There's nothing open on the stack. And so when we call main and we get this first activation record on the stack, this is the topmost thing on the stack, almost like the top tray of the stack of cafeteria trays. And because this is the topmost activation record, this is the one that will currently be executing. And so in main, this is where we're going to store the variables. So score gets stored here. And then what happens inside this main function is we ultimately print the grade is, and we call another function. What other function gets called? We're going to call the get letter grade function. So this function opens up on the stack. And now this function is at the top of the stack. And so main, as we saw earlier, what happens with main? Main is paused. Main is paused because only the function at the top of the stack is the one that's currently being executed. So while main is paused, this is what's running. This get letter grade, maybe when we called score, remember we said we could maybe send over 62. It's a bad grade, but oh well, life happens. We've all gotten those. So we send over a 62, and we're now doing this if else, if the score is greater than 90. If the score is greater than what? Greater or equal to 80 and 70 and 60. Finally, what happens though? Finally, we return a D. And what happens when we return a D? When we do this return letter grade right here, what happens? This activation record has finished. It's erased now off of the stack. It's done, and now main is no longer paused, and we're back at main, and we now have this score is, where we called it as, we said the grade is right here, and we had called this function, and we sent over a 62, right? And then all of that becomes a D, and it gets printed. And then once it gets printed, the main function, it gets removed from the activation record. There are no functions open, and then the program completes. This is the idea of activation records and call stack. So what happens when a function finishes execution? The answer is the program control returns to the caller. So once that get letter grade function completes and it's now returning that D, well, that get letter grade function is removed from the stack. That activation record is removed from the stack, and program control goes back to main, which was paused. Now it's no longer paused, and main continues. So that's just an introduction on function call stacks and activation records. That's really normally all we're going to talk about in this introductory course, but it's important to understand how that works. One final program. Write a complete program that will convert feet to meters and meters to feet. Your program should include the following functions: feet to meters, meters to feet, as well as a main. And here's what we really want to print. We want to come up with this exact output. Now, as you look at that, that should look familiar. Why should it look familiar? Because we coded something like this already with loops. I think we had a pounds to kilograms and maybe feet to meters as well, something like this. We've already coded something very, very similar. So the looping part should hopefully not be causing us too much trouble. We can see here that we need to loop 10 times. We can use feet as our looping variable. We'll do a for loop to go from 1 through 10, so 1 to 11. All of that should be easy. We recognize we have a meters. Meters has to go from 20 up to this number, but we're basically just going to add 6 at every single step of the iteration. All of that should hopefully be okay. What's new here is this idea of now making all of this inside functions. So I'm going to come back over here to our Thani, file, new, and what are we doing? We are length conversions. I'm going to call this file, save as, length conversion, chapter 6. And here we go. So we need to have 3 functions: feet to meters. I'm going to type those as is. Define feet to meters, and we need to send over the parameter feet. and I'll just put a comment, stuff here. Define meters to feet. I'm going to send over meters. Stuff here. Define main, our main function. Stuff here. And then finally, of course, call main to start the program. And we call our main. Cool. So those are the three functions we need to make. We have formulas. Here are the formulas. So we need to make these three functions. Let's go through how you would do this without functions. Let's first code up our main. I think that might be easiest. So in our main, we need to do what? We need to print the header of the table. So print what needs to get printed. We need to print this word feet, the word meters, this line, the word meters, the word feet. And again, I would go back and I would try to open up that code you've done previously where we had the pounds, kilograms, feet, and meters. Look at that code as a starting point if you need an assist. But try to pause the video and try to code this up on your own. And here is a solution that I'll be posting. So I think this is around, I'm trying to count here, guess. 1, 2, 3, 4, 5, 6. I think there's 4 more spaces. So I think each of these columns had a width of 10 spaces, but we have basically 4 things that need to get printed. Then we have a vertical line, another placeholder, dot format, and what gets printed here? We have feet, we have meters, and we have feet. Okay, let's run that. Before we do anything else, run it. Define feet 2 meters, expected an indented block. Okay, because it doesn't like that I don't have anything inside here. I'm just going to type return, and I'll leave it like that. And type return here. Run it. Okay, so here's the output. It doesn't look pretty right now because I didn't actually format these placeholders. So I think this is going to be left aligned 10 string. I think this will be colon left 10s. Here, this is going to be colon left 10s, and then colon left s. As you know, I don't need to put 10 because it's the last column. And I also need to put, if I run this, you're going to see it's going to be a little bit off because I need to put the spaces before the word meters. And it was 4 spaces, it looks like. 1, 2, 3, 4. So we run this, and that looks correct. So now that we have this header working, and it's formatted correctly, I'm going to copy paste the hell out of that. And I'm going to now use this in my for loop when I'm printing. So I need to do what? I need to loop from 1 to 11, and I'm going to use the word feet as my loop variable. For feet in range 1, 11, a step size of 1. I don't need to put the step size, but no harm, no foul. And what do I want to print? I want to print basically that same print statement. But now, notice that the first column has 1 digit after the decimal, so this is going to be 10.1f. This next column for meters has 3 digits after the decimal, so 10.3f. Here, the meters value of this third column has 1 digit after the decimal, 10.1f, and then finally 3 digits on the last column after the decimal, so 0.3f. And again, I'm not putting a 10 here because there's no harm in putting a 10, but there's no need. So what actually gets printed now, though, is here, what gets printed here? This is the feet value, right? This would be feet. What gets printed here? Well, it's going to be the result of converting feet to meters, that result. What gets printed here in this third column? It's going to be a meters value. So now you realize, oh, I need to make a meters. So make meters variable and initialize to 20. So meters equals 20. And of course, at every step of the iteration, we're incrementing feet by 1, but we also need to increment meters by 6. So here, inside the for loop, increment meters by 6 after printing. So just meters plus equals 6. So this will be meters here. And you know what? I'm going to put some values for now. So I'm going to put meters. And I'm going to put feet here just so we can print and see what we get. This is not going to be the correct answer, but notice feet, The first column and the third column are exactly what we want. Of course, the second column is not the result of converting. So what do we want to do? This value is correct. The third column is correct. But here, what do we really want to print here? We want to convert the feet to meters. So if we weren't using functions, we could simply do what? We could simply right here say that we could use this equation, and I could simply put 0.305 times feet. And then right here, I could say, well, given a meters value, how do I get the feet? Take meters and divide it by 0.305. So I'm just merely putting the calculation. So I'm printing 4 placeholders. The first placeholder is feet. What goes in the second placeholder is 0.305 times feet. The third placeholder is meters. The fourth placeholder is meters divided by 0.305. And I get this result, which is precisely what I wanted. But I'm not using those functions. So now let's use the functions, but you're going to see it's super easy. Feet to meters, given feet. How do we get meters? Well, we already saw it. Given feet, how do I get meters? I take 0.305 and I multiply it times feet. So I'm merely going to just return that value. Just return 0.305 times feet. Given meters, what do I return? I'm going to take meters and divide it by 0.305. So notice these two functions here were super easy. I'm merely just returning, just one line of code, take the parameter, multiply it times 0.305. Take this parameter meters, divide it by 0.305 to get feet. So now instead of doing the calculation right here, what am I going to do for the second placeholder? I'm going to call the feet to meters function, and I'm going to send over feet. And for this final argument here to the format function, I'm going to call meters to feet, and I'm going to send over the meters value. And let me close this and this so we can see everything on the screen. Let me run it, get the correct answer, and now just process what you're looking at. We have this feet to meters function, we have a meters to feet function, and then we have our main function. Are these functions really necessary? I mean, no, we did the calculations right here, right? There was no need for the function, but the whole purpose here is practice. And also the purpose of functions is reuse, that here I've made this function once. I can now copy that function out, put it into another program, right? So instead of putting the calculation here, by virtue of using a function, I can reuse this function in other programs. So now we have 3 functions, and we're calling that function, and we're getting this result. That's a lot. I did not go through this super slowly on this last example because I'm being cognizant that I'm already at 48 minutes, so I'm 3 minutes over really where I want to be. If you need any extra assistance, first and foremost, rewind the video. Watch again what you need to watch again. Chew on that a bit. And then, as always, reach out and ask questions. We will cover another example just like this one right at the beginning of the next video. We want to pick up right here and solve another one just like this. So make sure you're comfortable with this example. If not, reach out. Here's a solution here in the slides. It looks pretty much identical to what I just coded. Make sure you're comfortable with that solution, and we're done. As always, reach out. Ask questions if you need anything. It's been fun. Take care, everyone.